Hello everyone. I am Dr. Victoria ANAND Mary, Assistant Professor, PG and Research Department of Computer Science, St.Joseph College of Arts and Science, Autonomous, Cuddalore. In this presentation, we will learn about doubly linked list in data structures and algorithm paper, and the subject code is AI102. Let's have an introduction to doubly linked list. A doubly linked list is a data structure that allows two-way navigation. Each node in a doubly linked list contains data part and link parts. In the diagram, it's clear to see that the data part is used to store the actual value or information. And the link part, there are two link parts, one pointing to the previous node, that is left link, and the other one pointing to the next node, that is right link. This allows for traversal in both forward and backward direction, making this structure versatile and effective for certain operations like insertion, deletion from both ends. Now we are going to see about the create operation of doubly linked list. This block of code is for creating a single node in a doubly linked list. There is a constructor which initializes a dblist object with an element which is defaulted to 0 if no argument is passed. The L-link, that is left link or previous node, and R-link, right link or next node, are initialized to 0. And we are having a method that is create underscore dbl. This method creates a new dbl object with the value 11 as an element, assigning it to the first pointer. As a whole, the create dbl function is responsible for initializing the linked list. In this example, it creates the first node of the list with an element value 11. The newly created node is assigned to the pointer first, marking it as the head of the other list. Moving on to the insert operation. According to this block of code, we must be clear with the terms X and P. In this block of code, the new node is termed as P, which is going to be inserted after an existing node X. That is, X node is already existing. Let's break down this statements. First, the left link of node P is set to point to the node X. Then the right link of P is updated to link to the node that follows X. Next, the node after X is updated to point back to P as its previous node. Finally, the right link of X is updated to point to the newly inserted node P. And this operation inserts node P after node X while maintaining the doubly linked list structure, which is depicted in the diagram given below. The diagram gives the picture representation of the doubly linked list after inserting a new node P, and the address of the new node is 200 and the value being inserted is 15 in this diagram. Now let's take a look at the delete operation in a doubly linked list. This function is designed to remove a specific node referred to as X from the list. First, the function checks if the node is to be deleted is the first node in the list. If it is, delete is not permitted and the message delete is not allowed is displayed. This is the safeguard to prevent deleting the head of the list without any specific or special handling. If the node X is not the first node, the function proceeds with the delete operation. The right link or R link of the node before X is updated to bypass X and point to the node after it. Simultaneously, the left link or L link of the node after X is set to point to the node before X. This is the overall working of delete operation of doubly linked list. And by updating these pointers, the node X is effectively skipped in the list. Finally, the node X is deleted from the memory, ensuring that the list remains intact without breaking its structure. The diagram represents the delete operation of doubly linked list, and the shifting of address between the nodes is clearly depicted in the diagram. Now let's summarize. The doubly linked list is a type of linked list where each node contains data and two pointers. One pointer points to the previous node and other points to the next node, so that we may have a bidirectional traversal. This allows traversal in both forward and backward directions. And it is more flexible for operations like insertion and deletion when compared to singly linked list data structure. I hope this presentation would have given you a clear understanding about doubly linked list. Thank you all.